10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome back to Yacht Engineering Week 2021, Day 2. I am here with Paul Flannery. Paul, what do we got going on today?
So it's Tuesday, it's the second day of Yacht Engineering Week, and we've got several more segments to learn about today. We're going to start today from here at LMC, and we're going to talk a little bit about what the business model is and how it differs from some of the other yards in the industry. And you're going to take off with Dave, and you're going to see what goes on here at the yard. When we come back, we're going to talk to Wards about bonding systems and grounding systems and how they differ. And we're going to finish up the day with one of the most effervescent characters in the industry. Malcolm Elliott's going to teach you a little bit about surveying boats. So Heather, let's break off. I'm going to go see Amy. You go see Dave.
All right,
sounds like
good.
a plan.
Hi, Dave.
Hey, Heather, how we doing?
I'm Heather, nice to meet you.
So
Paul told me he is heading over with Amy to discuss LMC's business model a little bit, and that you're going to show me around the yard.
Absolutely. Let's head over to the West Yard and check out a survey hall that's going on.
That sounds great. Let's go. So tell me a little bit about the marketplace model that we have here at LMC.
So the marketplace model is a little bit different than other shipyards. We really put the captain's crew in control of their full shipyard experience.
Okay.
We've got 29 tenants on site that are part of the all the core trades for anything you'd need to do in a shipyard period, and also have a list of 300 authorized contractors that you can use during your shipyard period. We don't have any project management fees, any drop fees at the gates. It's all in your control of how you want to do the whole experience.
Okay, that sounds great.
Yeah.
So I see a lot of different businesses here. They're all contractors. They rent out that space, I'm assuming?
So yeah, we have, of the 29 tenants that we have on site, we have several contractors all in those key trades, from doing running gear, metal work, paint work, carpentry, electronics, everything there. We also have some brokerage houses on site, and also have aligned with several of the key builders in the industry. Ferretti Group has their service yard here. Choi Lee also does all their service work here. Princess does theirs through a group called Aquamare, and Benetti does all their service work. So those are a lot of the groups that we've aligned ourselves with. And it really works well with our marketplace model for the builders and management companies who really want to run their own shipyard period.
Awesome. So tell me a little bit about where we're heading now.
So right now we're going into the West Yard.
Okay.
In this yard we have two haul-out machines. One is our 220 Chimolai machine. We call her Brutus.
Okay. Now 220, what does that stand for?
So 220 tons is the max that this machine can haul out.
Gotcha.
If you want to step out, we can take a better look.
Sure.
So our 220 ton machine Max length on this is usually about 125 feet.
Okay.
And max beam is right around 32-foot beam. So that's generally what we're pulling out of the water with this. We also have a 100-ton well. That's around the 90-foot range of boats that we can haul out of the water. And then throughout the yard, we've also got 485, which is our largest.
Wow.
We can haul out boats up to 185 feet on that machine. So that's 485 tons being the max on that.
Gotcha.
And then a 75-ton lift for some smaller boats. A lot of the tenders to a lot of these larger boats we can haul out there. Lastly, we've got a 140-ton travel lift, which is retractable for catamarans. So we built that one so we can do boats with the larger beam, the catamaran, so that's up to 33 foot as well.
Okay, so what are we doing with this boat that's coming out of the water here?
So this boat is just going back in from a survey. We do all kinds of different work on boats, from surveys for sale. They'll just come out, check the bottom, check the running gear, see that everything's good for the boat to be sold. And then we do, as far as even bigger projects, you can see over here, this boat's been hauled out for a full refit, full paint job,
Wow.
10-year survey, everything from there. So wide range of different kind of work that can be done here at LMC.
Yeah, it seems like anything that a boat needs, it can come here and get it done.
Yep, and any kind of work, and then any kind of size range. We've got over 200 slips here on site, about 100 on the hard, 100 in the water, and they range from our marina on this side to the working slips over in the basin. So really that wide variety of things that we're offering, and really making that you're in control of your shipyard experience, and we're here to accommodate you the best we possibly can.
Awesome. Well, thank you, Dave. Is there anything else that I missed that I should have asked that I didn't?
No, I'd love to. We'll take you back around to the around the basin. You can see some other work that's being done in the yard.
Okay, perfect. Let's go.
All right. Well, everybody, I found Amy. We're at Yacht out on the docks at LMC. And Amy and I are going to have a bit of a conversation about what goes on at LMC and what makes it different here. Nice to see you, Amy.
You too, Paul.
Long time. You okay?
Yes, very well.
Good, good. It looks like things are kind of busy around here.
We are very busy.
Let's-
It's season. We're taking care of everyone and making sure they get their work done and ready to roll. Head to the Bahamas, head to New England,
There
maybe
you
the
go.
Med.
It's almost time to go.
Mhm.
Very cool. Well, you know, as we've talked about a little bit in the past, and I want to revisit. LMC has a bit of a different model. I know that Heather and Dave have talked briefly about the business model here at LMC as it differs. Give me a little oversight, or dig in a little bit deeper as to what makes LMC different than your standard drop it off at the yard, drop the keys off and call me when it's done.
So there are a few different types of models. The model we have here is called our marketplace model.
Right.
We use the analogy of, we supply the dance floor, you bring the dancers. You
Okay.
make the decisions. You are in control. You choose your contractors. You run your schedule. You manage your project. We are here to elevate the experience and make sure that all the chaos is kept behind the scenes.
Okay.
And make sure it is efficient and meeting your needs.
Okay, well, I would imagine that that speaks right away to some cost savings because you're not paying somebody else to manage your project, right?
Correct.
So there's something I'd like to drill down on a little bit, and that is most people are accustomed to having a project manager, and that's whether it's a 40-footer or a 400-footer. They're used to being able to just have one go-to guy. How is it that you guys differ from that?
We let those decisions be made by the crew. The crew, the captain, and the owner. We do have project management available on site
Okay.
if they so choose to do that, if it's a larger project. But normally, their top priorities are schedule, cost, and just the timing of everything, because they have to meet their owner's schedule or their charter schedule, so they control that.
So if you want a project manager, that service is available, but it's a subcontractor just like an air conditioning guy would be, or like a alignment or a propeller guy.
That's correct.
Okay, so you could coordinate through there. And what you guys do primarily is, as you said, provide the dance floor. So you got an appointed time that you show up at the dance floor. what it is, what music you want and what dance you're gonna
That's
you're gonna
correct.
try,
Yeah.
and then time that you don't have to go home, but you can't stay here.
That's
kind of
right.
thing.
Yeah,
Okay.
party's over.
All right. So as long as you don't ask me to sing, I think that would probably work
Yeah,
out pretty well.
Exactly.
All
It's
right.
been very successful, and every captain has their own choice of how they'd like to handle it. And people have really made that a priority, so they choose to come here and
Right.
they choose our model.
Well-
We do have approximately 29 contractors on site that
Right.
kind of fulfill the core trades of underwater, running gear, zincs to
Paint, electronics, to
paint, yeah, exactly. Paint,
HVAC, everything.
and we also have an authorized contractor program that allows another 300 contractors to come in. So it is the choice of the captain and the owner to decide who they want to work with.
I got to tell you something. That's someplace where LMC and IYBA align so beautifully, because our mission statement is to promote professionalism and cooperation in the yacht sales industry, and we do it through education, networking, and the removal of barriers to commerce. LMC is the first yard that I know of that has put a program into place
Yeah.
that requires that people meet a professional standard, that they have all the proper licensing and insurances. And if I'm not mistaken, that model has promulgated into a lot of other places in the area and throughout the industry in maintaining
We
a high
hope
level.
so. We always talk about ensuring that we keep the industry in South Florida
Right.
and the Venice of the United States, if you want to call it that. But we want to promote the younger generations to stay in this, this industry and work on the boats and, work for a running gear, hydraulics, any type of company that we have available. So
MIASF is doing a really good job
Mm-hmm.
with their Salty Jobs initiative and bringing the message into the schools. One of the things that we helped the state of Florida's legislature understand when we got the sales tax cap passed back in 2010 was that all of this work isn't giving rich guys a tax break.
Mm-hmm.
And it's not, the evil big white boats. It's about jobs, and it's about jobs that pay 28% higher than the
Exactly.
same trades in a different industry, in the residential or commercial construction industry. So these are good things. These are good messages to get out into the community, is that it uplifts a community to have a facility like this where you've got tradesmen that have a place to ply their trades, and they can provide services. Everybody knows, we've talked about it 100 times if we've talked about it once, that when a boat is in the community, 10% of the value of that boat is injected into that community on an
Exactly.
annual basis,
Yeah.
and 13% of it in the first year that the guy owns it. So this is a great place
Yes.
for that 13% to land.
Exactly.
But it doesn't land in your pocket or mine. It lands in everybody in the community's pocket, from the people that do the HVAC work to the people that sell shoes and work in restaurants and drive
That's right.
Ubers.
Yeah.
So it makes a big difference. So one of the other things that you guys provide here that has become a little more popular over the last couple of years is an FTZ. Let's talk briefly about an FTZ, what it is, and actually we could probably walk out and look at what an FTZ looks like.
Yes,
Can you show me an FTZ that we'll understand?
I can.
That's awesome.
So the FTZ is the Foreign Trade Zone.
Right.
We work closely with Customs and Border Protection.
Okay.
They are the regulators of it. So we are under the umbrella of MIASF.
Right.
And what it is a designated berth at Lauderdale Marine Center, or there are many FTZs out in the industry.
Right. Yeah. The HMR has them. Pier 66
Yeah.
has them.
Yeah.
And some of the other shipyards have them as well.
And it allows a vessel, a foreign flag vessel, to come into our designation
Right.
and either sit for sale to U.S. buyers as
Right.
well as anyone else. You can do duty drawbacks. You can also haul out or do work on the vessel and have a tax break. So tariffs would be tax-free, and that is called production authority.
Okay.
And Lauderdale Marine Center is the only one right now.
That has production authority.
Correct.
Okay.
One also great thing that benefits someone coming into the foreign trade zone is the mere size of our facility. If you have a sale transaction, survey hall 99% of the time can be scheduled. and we can get you in and out of the water in a timely fashion.
Well, and that was
and
one
efficient.
of the original motivations for the FTC, was the fact that foreign flag vessels, when coming to the United States, are required to apply for a cruising permit. And the cruising permit, when granted, stipulates specifically that this vessel is not available for sale or charter to U.S. residents while in U.S. waters. The FTZ provides the brokerage community an opportunity to offer that boat for sale to U.S. residents while it's not in U.S. waters,
Correct.
even though 13 seconds before the water may have been in U.S.
Yes,
waters.
exactly.
It's now international water,
Yeah.
and then as the tide moves, it's U.S. water
Correct.
again.
Correct.
So the water itself isn't what's considered, it's the location. But it allows that business to be transacted,
Correct.
and it removes that discrimination against U.S. residents
Yes.
for boats that are here, and it can be sold to them.
And it makes it very efficient for the brokerage community.
It does. It does.
To
Another
sit
thing that it
here,
does
yeah.
is it makes it efficient for the new boat manufacturer as well.
Exactly.
For example, if a new boat manufacturer has their North American distribution here in the United States, but a boat may come from a foreign builder, it can come here and be rigged and not have the duty paid on it before it's sent out to Mexico or Venezuela. Well, nobody sends anything to Venezuela
Yeah.
anymore, unfortunately, but it could go to another foreign country without it having to be duty paid and then apply for the duty
That is
drawback
correct.
later on.
Correct. We work with our on-site builders and do that right now. So right now we have Choi Lee
Right.
on-site, and we bring all of their boats in
Okay,
through the foreign trade zone, and they sit for sale.
right,
And then they can go to a boat show.
right,
And because we do require a subrogation bond, they do not need to purchase a boat show bond as well.
okay, all right.
So we're working with the other builders to do the same.
They can also bring the, if I'm not mistaken, they can bring the boat in here to the FTZ from the manufacturing facility, not pay duty on it, transact the business of that boat and put it in a foreign flag and not have to have dealt with the U.S. duty considerations.
Correct.
And if the owner wants to flag it U.S. or import it at a later date, he's welcome to do that, but it's not complicating the process, it's simplifying the process.
Correct. And that's what we try to do, is simplify everything for the builder, the user, the broker.
Right.
And it just defers the duty down until someone wants to pay the duties.
Right.
Yep.
So you have Choi Lee, you have Ferretti, you have...
We have Bonetti, we have
Bonetti?
Princess through
Okay.
Aquamare
Okay.
on site. And we are the yard of choice for San Lorenzo, Majesty. And we also work with the management companies that,
Sure.
work with us to do the same things.
Very cool.
Yeah.
Very cool.
Let me show you just how we designate it.
Absolutely.
It's a simple
Let's take
process.
a walk out. We'll leave our coffee here. I hope nobody steals it.
Maybe they'll put some
Don't mess my
sambuca in it.
Yours, it would be okay.
Yeah. I don't think Doug would like
So
that.
Sinbad is a boat that we did another segment on.
Oh, really? So
Yeah.
let me show you.
So this is designated as an FTZ.
Correct.
Okay. So the audience can see that here you've got a special designation. So this slip is in an now is this boat in the FTZ?
No, it is not.
So the slip can be utilized as a free trade zone, but it doesn't have to be empty if there's no non-duty paid vessel there.
Correct.
Okay.
Yeah.
So it's
We
done
can,
via
though-
paperwork.
Everything is, yes, done by paperwork. So we have to
Okay.
do a domestic entry
Right.
for a vessel that is not being entered into the foreign trade zone.
Okay.
Otherwise, we just do a formal entry of a vessel, foreign flag vessel coming in.
Okay, so I know a question that rings around the brokerage community a fair bit is if the boat is in the FTZ, and let's say it's a boat that is owned, not one that's an inventory boat, and the owner wants to take the boat out and use it, can he take it out and then bring it back into the FTZ? Is he subject to duties? Is there a form he can fill out to take the boat out?
So if a vessel has been entered, the vessel can depart the designation,
Okay.
but not for pleasure use.
Okay,
It can depart for a survey haul,
Okay.
work to be done,
Okay.
to be showcased at a brokerage open house,
okay.
a boat show.
Right?
and otherwise it cannot be used for pleasure.
Okay.
If an owner would like to use it for pleasure,
Right.
It has to be withdrawn,
Okay.
and the options are touch a foreign port
Right.
as a withdraw or pay the duties.
Okay. All right. So he could take it out of here. He could go to Bimini, the Abacos,
Correct.
or Bermuda, or to the Med and come back.
And that would finalize the FTZ program.
Okay. And then he would initiate a new program if he wanted to
Correct.
bring the boat back in. And is there a limit as to whether he's allowed to bring back in or not?
No limits.
Okay.
They can stay in the foreign trade zone as long as they'd like.
Okay.
We, as an operator, require a subrogation bond that lasts a year.
Okay.
And that covers 150% of their duty, of the duty risk.
Okay.
So the 1.5% of the value of the
So
vessel.
calculate the value of the vessel, multiply
Right.
1.5, and then 1.5 times that, because
Correct.
the duty would be 1.5. So 1.5 times the liability of duty would be what the amount of the bond is for, not that you have to pay that amount, whatever the insurance company designates as the
correct.
value of that
Yeah.
bond. Just like a yacht broker's bond is for $10,000, or a yacht salesman's bond is $10,000, but he doesn't have to put up $10,000. He pays $101 or whatever it
Okay.
is that he pays.
So they do have to pay for the bond.
Right.
And it is good for 1 year. And if they stay longer, we have a couple vessels that have been here for more than a year, and then we just execute another bond.
Right. So you just renew.
Yeah.
Okay. Awesome. Amy, that's really interesting. It's really important information. It gives us a good sense of what's different about LMC from some of the other facilities, the model that you guys have. We're going to cut back over to Heather and Dave because they're rolling around the yard, and I think this is a perfect opportunity to see what they're up to. I think Dave's showing her the different lifts, and I think she's
Yes.
pretty surprised at the size of them. So we'll go back out to Heather, and we'll see you on the next segment.
So as we're coming around, we do have 17 out-of-water sheds on site.
Okay.
So a lot of paint jobs are being done in these areas. Any kind of teak work, anytime there's any openings in the boat. We've got 17 of those out of water, and then 8 of them in water. So once again, that's just shows the variety of things that we can show to the boats, accommodate their different scopes of work that's
Of
going on.
course.
And
Yeah.
then as we're coming through, you can see we have some of our bays for a lot of our tenants. Wide variety of shipyard trades that we have here on site.
Yeah, last year when I was filming Yacht Engineering Week for the first time, I didn't even know that this whole thing was here. I didn't even know about LMC, and I live right across the street. So
So-
it's crazy that this huge facility is right in the heart of Fort Lauderdale, and I had no idea.
Yeah, being all the way upriver here, it's a little bit hidden from everybody, but on that side of it, we're also kind of all the way up for we're a hurricane-safe marina. Good place to come during that hurricane season.
Yeah, now when you say hurricane safe, what do you mean by that?
So we're 4.5 miles up the river,
Okay.
so you don't get as much of the storm surge. Being so far inland here. We also are brand new marina, new docks there, sturdy seawalls, good place for everybody to tie up. We also do different having the ability to haul out so many boats with the 5 different machines that we have. We can do upwards of 17 boats a day if need be.
Wow.
So in the case of a storm, a lot of people want to come out of the water.
Sure.
And that's when we're hustling around and making sure we can keep everybody as safe as possible.
Gotcha. So I'm sure hurricane season is pretty busy around here.
It certainly is. It's when a hurricane comes in, we definitely go into a different mode. But we've got a great team here to make sure that we're accommodating everybody to the best of our abilities and make sure everybody's nice and safe.
It's great.
Yeah.
So where are we heading now?
So this is the basin.
Okay.
This is where a lot of the bigger boats do any of their in-water work.
Okay.
So these slips, they have crane access, which we can offer to the boats, forklift access. Oftentimes they're doing paint jobs in the water if they don't want to come out of the water.
Really? They can do
Yeah.
paint jobs in the water?
Yeah.
Wow.
So we only have a few spots that we can do that on this side, but it's just sometimes the option that boats decide to do. If they've already hauled out in the past, we do our best to work with their schedule.
Okay.
And then our slips continue all the way out to the east. These are more 160-foot slips. We've reconfigured the marina over the last few years, so that we have about 60% of our slips, both on the hard and in the water, are over 100 feet.
Okay.
So this is the 485 well. We expanded that when we got the new machine, which is the Beast over here. Once again, that's trying to accommodate the bigger vessels to the best of our ability.
Wow, I see why they call it the Beast.
She is a beast. Right now, this boat going back in the water after coming out for a bottom job. Boat just sold, so they're changing the name, doing some painting, and some touch-ups, getting it ready for the new owner.
Awesome.
Yeah, and as you're coming through, all different kinds of projects going on throughout the yard. We have people doing plating work on the hull, full paint jobs, bottom jobs, a lot of running gear works going on, 10-year surveys, and then full shipyard, full refits as well.
Wow.
This boat over here has been here for about a year, doing a full engine swap and teak repair. But yeah, it really ranges in many things. You can come out for year refits, or just coming out for a quick bottom job for a week.
Wow, well, it seems like LMC is the one-stop shop for all things yachting.
That's what we try our best to do.
All right, well, thank you so much for the tour, Dave. I really
Awesome.
appreciate it.
My pleasure.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. We'll be right back.
What does a boat built for towing oil rigs have in common with a boat built for recreation? Neither one has any room for error. And no one understands this better than Hargrave Custom Yachts, because their customers are looking to relax, and they know their boats never can.
There's a lot of challenges when you're running a charter boat. A lot of times people don't really realize the behind-the-scenes stuff. It's not like the freighters or the fishing boats. Yachts go out in fair weather, and I've been very fortunate. I've only gone through a couple of really bad storms, but I had to get in Antigua for a charter boat show. These dates are hard set. I reluctantly set off. Day 3 into a 4-day trip to Bermuda, we just hit it hard. We're in 30-foot seas with 70-knot winds. I mean, we were kind of holding on here. The boat was rolling so hard that there was not enough water in the bilge for the pumps to work, because at one point the water was all the way at this side, and the other point it was all the way at that side. And I realized that when that clutch pump goes to 60 minutes an hour, we're sinking. And I'll tell you, thank God for, engines, because that damn engine got me all the way to Bermuda and kept that pump running.
When we started this company, I didn't have many absolute must decisions, but the first one I made was we were going to go with Caterpillar, because I'd worked with all the other companies. I worked for them a long time, and the only person at the end of the day, when you really put the pressure on, the only person that showed up was Caterpillar. And what makes Hargrave different is we understand that those few weeks, those few days that the guy's on the boat, there can't be any excuses, none. He doesn't want to know anything. He doesn't have time. The minute he gets 1, 2, or a third excuse, he's out of boating forever. It's depending on you to tell him what he really needs to know. He doesn't know this business. He's absolutely trusting you. Tell me what I need to know, and that's why I've told him, put Cat engines in.
The bottom line is these boats have to get there. Boats have to get from Newport to Antigua or to the Mediterranean, Gibraltar. and Teebs. And these boats go through the same stuff that every other boat goes through, and they look great, but you know, they have to be tough too.
From heavy swells to fair weather, the sea offers no guarantees. But through it all, customers can count on Hargrave Custom Yachts to be there for them, mile after nautical mile.
Okay, and we're back. That was an interesting segment. What did you think about taking a ride around the yard? What did you see?
You know, I took the tour last year with Doug, who doubled as a race car driver. But today, Dave gave me a tour and we went all around the yard. It was great to see everything again and get a refresher. There is so much space here, so much property, so much land, so much waterfront that I really needed a refresher on where everything was. So thank you, Dave, for the tour.
Well, the yard has an awful lot to offer. It absolutely does. Our next segment, we're going to go to Ward's. We're going to learn the difference between bonding systems and grounding systems, and there the twain shall meet. Welcome, everyone, to our segment on electricity. This year, we've got a great opportunity. We're meeting with Ward Eshelman at Ward's Electric. Ward, thanks for joining us today.
You are welcome.
Thanks for being here. Ward's going to talk with us today about electrolysis, or galvanic corrosion, as it's properly referred to. And we'll talk a little later on about grounding as well, the difference in the systems and what makes one specifically different from the other. Ward, one of the things that we talked about before our conversation even began here is you were going to convince me to dispel the use of the word electrolysis. Tell me why that is.
That term is used a lot in the corrosion business, in the marine corrosion business, but it is used probably most of the time improperly. Electrolysis is a chemical phenomena that happens to the electrolyte or the water that a boat is sitting in during current passage through the water. It could be straight current, it could be galvanic current, the type of current doesn't matter, but it is a breakdown chemically of seawater and breaking it down into the two hydrogen and oxygen gases. So it's what happens to the water. It's not what happens to a metal that may corrode, whether it's a metallic hull or a through hull fitting. So really the proper term within our industry or any industry that's involved in corrosion is using that term corrosion. Now there are many different types of corrosion. As you mentioned earlier, we have galvanic corrosion, we have straight current corrosion. Anodic protection, cathodic protection is actually a form of corrosion in and of itself. So I have been on a mission for many years to correct that within the industry. And I have to be honest, we at Ward's Marine Electric many years ago called our corrosion surveys electrolysis surveys, which was incorrect. We changed it many years ago to corrosion surveys.
So I want to back up just really briefly. And you know, we as lay people, the general public, we think of corrosion, we think of rust, we think of pitting in aluminum. That's what we consider to be corrosion, or that's what we would normally think of when we use the term corrosion. Tell me why we're calling this corrosion. What is the actual effect that occurs that we're going to talk about our bonding system, and we're going to try to avoid the existence of the corrosion?
Well, corrosion isn't always necessarily detrimental. You had mentioned rust as being a form of corrosion, which it certainly is. But in essence, rust can become actually a protective coating for steel, iron, those types of metals. So that's a case of corrosion, yes, which can be detrimental, but it also can be protective in nature. Now, most of the corrosion that we see in the marine industry is harmful in nature. And I had mentioned earlier, one form of corrosion is straight current corrosion, where we actually have electrical current leakages on a boat that end up contacting something in contact with seawater. And then causing a corrosion of that metal to another. There has to be an anode in this particular corrosion cell and a cathode. The anode is the metal that is deteriorated or sacrifices into the electrolyte that I mentioned earlier, and then plates out on another piece of metal, which is called the cathode, in a electrochemical corrosion cell.
So when we have any time that we have two dissimilar metals in seawater, we've created what?
That would be a galvanic cell.
Action, right? So what we've done is we've created a battery, in essence. And
yes.
Is that correct?
That is correct.
So the electrode and the cathode, tell us in 101 terms, What is the electrode and what is the cathode in that environment?
Okay, well, they're both electrodes. One is an anode
Okay.
in a corrosion cell, and that is going to be the less noble metal, higher potential metal.
Okay.
It has to be, in order to have this corrosion, there are 4 requisites that have to be met. It's not just enough to have the 2 pieces of metal in contact, even close to each other in seawater.
Okay.
They won't corrode. There has to be an electrical connection between the metals.
Okay.
So there has to be an electrolyte, which in our case is seawater.
Okay.
There has to be an electrical connection, which can be metal to metal contact, or it can be bonding type or grounding type contact.
Okay.
There has to be a potential difference between the metals, which we're talking about. Typically, an anode is going to be a higher potential metal,
Okay.
and a cathode is going to be a lower potential metal. Let's say if we interconnect steel
Right.
to bronze
Okay.
in seawater, and they're electrically connected with a conductor, and we have a resultant current flow, which is called galvanic current, then we start a corrosive cell, which will be harmful, detrimental to the anode, the steel, and protective in nature to the cathode, the bronze.
Okay. All right. So the one that we're most familiar with in the marine industry when it comes to the nobility of metals, obviously, is zinc. That's the one that we all know. Everybody in the marine industry knows that you got to have zincs on the boat. You got to have them in the engine, you got to have them on the shaft, or you got to have them on the hull, and they've got to be on the bonding system. Let's talk about that bonding system and how zinc plays into that system, and what are we doing with that actually? We connect everything. What does that do?
By connection, and referring to the American Boat Yacht Council electrical standards, there is a standard E2, which is the cathodic protection standard. And bonding has been, the name has been somewhat expanded to cathodic bonding.
Okay.
And the purpose of that bonding is to interconnect the metals that are exposed to seawater. Let's say if we're talking about a fiberglass hull, we would include the running gear, rudders, struts, propeller shafts, through hull fittings of any type that are metallic in nature, inlets, discharges, bow thrusters, stern thrusters, all these types of equipment. In order to be protected by sacrificial anodes, like zinc, it's one of 3 major types of anodes, they must be bonded with this cathodic bonding system we're talking about.
Okay.
In order for the protection, the protective current from the sacrificial anode, the zinc, to reach the metals that you want to protect.
So what you're doing is you're drawing that current to the least noble of the metals and letting it be the one that corrodes away or erodes away, and thereby protecting the more noble metals, be they bronze, steel, whatever the case may be, because they're higher on the table of noble metals. Is that a correct interpretation?
Well, they're actually lower, or excuse me. Zinc, if we take the galvanic series, which
Okay.
is, it basically is a ranking of all types of metals from least noble to most noble. And
Okay.
when we say higher potential, we'll have zinc is relatively near the top,
Okay.
and the lower potential metals are near the bottom. So there's a pretty good potential. When I mentioned potential, we use in our industry a type of what's called a reference cell connected today to a digital multimeter to measure these potentials.
Okay.
The reference electrode that's widely used in the industry is called a silver-silver chloride reference electrode. So in measuring these the potential of all these metals, they have a inherent potential level when they're open circuit in seawater. And with the galvanic series, we're going to start again at the top with zinc being relatively high. There are other metals that are higher than that.
Okay.
And down at the bottom are going to be your copper-based alloys that we were talking about, like bronze.
Okay.
So when we interconnect, as we talked about, we have a form of corrosion where we have an anodic and a cathodic set of metals, we have galvanic corrosion.
Okay. All right. So in practical application, brokers out at the shipyard, Malcolm Elliott's underneath the boat. He's done banging on things with his hammer. He reaches over into his bag and he pulls out his multimeter. And he puts one of the leads on the prop nut. At first he scrapes a little bit of the anti-fouling off of there, or some of the prop speed, and the owner is shirking and cringing, and the yard is rubbing their hands together because we got to put more prop speed on there. But he gets to a good positive connection with the metal itself, and then he goes with the other lead to the zinc, or the stud on the zinc on the back of the boat. What is it that he's testing, and why is he testing that?
It's testing for resistance between these two separate metals.
Okay.
And if they are bonded together, then that resistance should be very low. And again, according to ABYC standards, any bonding system, you would like to see less than 1 ohm of electrical resistance between anything that's included within the cathodic bonding system. So that's what he is testing and measuring for, resistance in ohms.
Okay, and when we say bonded, we mean connected. Basically, that there is a positive and solid connection between those two pieces of metal through the system, and there is a sacrificial anode attached to it that's going to be the one that goes away.
Correct, and the resistance has to be very low because the current that's generated between the zinc anode and the metal, whatever metal it is protecting, is a very low level current. So it doesn't take much electrical resistance to block that current, which would render the anode, sacrificial anode, ineffective at protecting the metals. So the resistance needs to be very low.
Okay, all right. Is there any other way to protect the system besides having a zinc on it?
There are other methods.
Okay.
When we've been talking about zinc anodes, they are sacrificial in nature. They're not controlled in any way. It's the inherent current flow between the zinc anode and the metals it's protecting. There are systems called impressed current cathodic protection systems, where you have anodes that do not corrode. It's usually platinized titanium, and you force platinized titanium.
Sounds expensive.
It is. Okay. But impressed current systems, one of the major advantages is you have very precise control over the amount of cathodic current that's being produced.
Okay.
So you can preset a potential level, an exact level, and that control system will control the current that's being used to cathodically protect the other metals at a precise point. Whereas with a sacrificial anode system, you really don't have a lot of control. Normally you're going to put on enough anode material, whether it be zinc anodes or aluminum anodes or magnesium anodes, that you really end up probably having a higher protective level than you need. And then as the anodes are depleted, which is what they're supposed to do, they're supposed to corrode, you're absolutely correct, to protect the other metals that are comprised in the bonding system. Whereas with an impressed current cathodic protection system, number one, you have very precise control over the potential. Go back to the sacrificial anode system again. I'm going to use some numbers here just to give you an idea of what happens.
Please.
Let's say a typical fiberglass hull with bronze and stainless steel underwater metals that are bonded. That mixed potential unprotected is probably in the area of 300 or 400 millivolts to silver chloride, as I mentioned earlier.
Okay.
To cathodically protect those metals, we want to raise that potential by at least 200 millivolts. So that takes us up to the area of 600 millivolts for a minimum level of protection. Well, if you put enough sacrificial zinc on a boat to hit 600 exactly in a short period of time, as the anodes deplete and you lose surface area,
You're going to 500, you're going to 450, and you're
exactly.
going pretty soon
So
to 4.
normally, we see it in our corrosion survey work all the time, most fiberglass boats probably are at a potential level of 800 or 900 millivolts, which with time, as the anodes deplete, that potential will start reducing down closer to the 600 millivolt point. And that's the point where you really need to renew, either clean or renew the sacrificial anodes.
Okay. And those systems have been around for quite some time, haven't they?
Yes.
Okay.
Yes.
And you said, is that the only other way to protect other than sacrificial anodes?
Well, another important part of the protective scheme are coating systems.
Okay.
Very important. And usually not always with sacrificial anode systems or any kind of cathodic protection system, it's based upon a reasonable coating system of metals.
Okay.
And protecting uncoated metal is going to take a lot more protective current and therefore consume anodes a lot faster than one with a coating system. Now, coating systems are never perfect. You would like to get there, but you don't typically get there. But so really with a protective system like that, you're taking care of the breakdowns in the coating system. Extreme example, if you had a steel hull that was uncoated and had to install sacrificial anode weight, mass, size to protect that versus one that had a good coating system, big difference in the amount of sacrificial anode mass that you have to use.
You'd have
big
to have
difference.
A lot more.
Yes.
Okay. All right. So we've got a bonding system that connects all these metals that we want to protect from corrosion. And we use one of 3 different systems to do that, or generally used 3 different systems. This is an isolated and closed system per se, isn't it?
Yes.
Okay, all right. So we're only talking about one specific incident. Now, electricity is kind of black magic to a lot of people, myself included. I know to turn the power off before I change a circuit breaker, but I'm not really well versed in it, as most of our audience probably isn't. So we have a bonding system, and is it different from a grounding system? How does it differ from how we ground? Is ground the same with AC and DC? Because virtually every boat out there that we're dealing with for our audience has a bonding system, it has a DC system, and it has an AC system. How do these captive systems differ?
They're similar in many ways, but if we go back to the ABYC standards again, ground on board a boat on a non-metallic hull is described as the main engine or main engines or their bus. In other words, the engine blocks.
Okay.
That's the heart, that is the main point of the grounding system on board a boat. Now, ground is actually, if we talk about shore-based ground, it's earth.
Right.
Earth is ground.
To earth. Right.
Now, in the marine environment, with a boat that's in the water, in seawater, for our purposes here, ground is really the water that the boat is sitting in.
Okay.
That's ground. But the ground point on board the boat is going to be the main engine, negative terminal, or its bus electrically. Okay. Now, ultimately, both a grounding system, which basically is used with AC and DC systems to interconnect the non-current carrying parts of all the electrical equipment on the boat. The enclosures of electrical control boards, panel boards.
Okay, the non-current carrying components.
Meaning, or motor frames.
Right.
Pump frames, all those types
Housings,
of things.
Sure.
So it's there in AC applications, 120, 240 volts AC, it's there largely for shock hazard protection to people.
Okay.
Main reason behind it. DC, which poses much less of a shock hazard.
Yeah, we don't lose too many guys to DC, do we?
No.
Okay.
AC, because of the much higher voltage that you're dealing with.
Right.
DC, we have grounded systems. You're right, like a 12-volt DC system or a 24-volt DC system, and in the old days, 32-volt DC systems, which we don't see very much anymore,
right?
are usually the negative side of that system. The DC system is intentionally grounded.
Okay.
And the same thing for 12 and 24-volt systems. So, and then ultimately, in theory, you would like to have one point on the boat where the AC, DC, grounding, and the cathodic bonding system connect to.
Okay.
From an electroengineering design standpoint, that's what you want to have. In the real world, you end up with a lot of what are called parallel paths to the ground. But again, cathodic bonding is there to interconnect the metals that you want to protect with a bonding, with a cathodic protection system, whether it be sacrificial in nature or impressed current, like we talked about earlier. So there are things that are one and the same for these systems, but they all do different things for different purposes.
Okay. So we have a DC ground and an AC ground will be completely separate, though. You wouldn't ground AC to your engine block, would you?
Yes, you do.
You would? Okay.
Oh, yes.
So you can use the same earth or ground for either AC or DC.
Correct.
Okay, and how do you, is there any worry or concern of that ground feeding back the other way from one system into the other if you're using a common ground place?
No, because again, a grounding system, which will include bonding, is normally not carrying current until something goes wrong.
Okay.
You have an electrical fault. You have a short circuit. If it's a 120 volt appliance or a 240 volt appliance, and you have what's called a ground fault of a live or energized section to ground, that current is carried back to the ground point, and the power sources have grounding of what's called a neutral conductor, and you'll end up tripping a circuit breaker or blowing a fuse.
Okay.
in those situations, so for safety purposes. So there's no problem with back feed. There is a unique problem with shore power systems, since we're talking about AC systems on boats.
Okay.
Shore power systems, which a lot of boats have today, you look at the changes through the years, you know.
Oh, absolutely.
There are boats today
we used to have those nice light little 30 amp cords. That was all we had.
Right.
Now it's 100 amp cords and bigger.
It's amazing how much this has progressed, but we have a unique problem, corrosion problem in our industry. When a shore power cord is connected between the boat and the dock, there is a grounding conductor in that shore power cord.
Right.
If it's a 120, 240 volt single phase cord, it will have 4 conductors in it, 4 wires. Line 1, line 2, neutral, and ground.
Okay. Line 1 is 125 volts, line 2 is 125 volts, so that gives you your 250 volts.
Exactly.
And then you have your neutral and a ground.
And the grounding conductor, by design, interconnects the boat's ground, which again, the main point on a non-metallic boat is going to be the engine or engines, propulsion engines, back to the dock ground, or essentially earth.
Okay.
So it sets up a galvanic corrosion cell, which typically the boat is at a higher potential than earth or the dock ground. So what happens now, you have a path for the protective current from the sacrificial anodes are not only trying to protect the metals on that particular boat, that protective current is lost back to the dock.
Ah, so it's doing a bigger job than it was designed to do.
Exactly.
So in the design phase, how do we accommodate for that? Because knowing that, let's just use as an example a 60-foot motor yacht, and you're charged with designing the electrical system in that boat. How do you accommodate for the fact that that boat's going to spend, let's say, 250 hours a year underway on its generator and independent of shore power, and it's going to spend all the rest of that time connected to earth? How do you accommodate for that?
There is an electrical device called a galvanic isolator.
Ah, okay.
Which was developed actually a fair number of years ago. And it effectively it's installed in the grounding conductor circuit on board the boat. It's not at the dock, it's at the boat. So anywhere that boat goes, it receives
brings that protection with it.
And effectively what it does is it blocks that low-level DC or current that I'm talking about that causes the anodes to work harder and therefore sacrifice faster. It blocks that low-level, it's actually a DC voltage that's created there. And not in terms exactly of like a 12-volt DC system, but just the potential difference that I talked about earlier. It blocks that galvanic current flow, but it maintains the integrity. Again, the main reason for the grounding conductor in AC systems is for shock hazard protection to people on or near the boat.
Okay.
So you don't want to disturb the integrity of that, so it looks like a short circuit to alternating current, meaning when I say it passes right through the device. It's not impacted by that at all, but it blocks this low-level DC voltage and resulting current that can cause accelerated anode deterioration and greatly accelerated at times. So it's a device that typically, on an OEM basis, the builders are installing. In the aftermarket, we install a number of them too, but it's a simple device. It really is passive, and it does probably one of the greatest services, because years ago, this was a big problem in the industry.
Yes.
Big problem.
Yes.
And because if you lose the anode area down to a point where your metals aren't protected, then they're going to start corroding.
Your short cord's going to cause your boat components to start corroding.
Yes.
So is a galvanic isolator something that requires any maintenance, any renewal over a period of time, any inspections? Is there anything about a galvanic isolator that the audience could know that maybe they didn't know before they tuned into this?
The tests should be performed on some type of periodic basis, because one of the major components within a galvanic isolator are diodes. They're solid state components. There are typically 4 of them. They could be impacted by lightning strikes, and I'm not even talking about a strike that hits the boat or the dock. This could be some distance away that could
even a
compromise.
Power surge. If you go to a third world country where you don't have stable, clean power, that power surge could create an issue with the diode. Correct.
Correct. And you can't just visually look at a diode and tell whether it's functional or not. There are tests that could be performed, which are really quite simple. So that's something that's important because you can't visually look at a galvanic isolator externally or internally and tell if it's working. There are tests that can be performed simply with a digital multimeter that can prove that the components are indeed good.
Okay. And is that something that you would recommend people do on a periodic basis, maybe annually, or after you've made your summer season trips to foreign ports or places that you aren't 100% sure, or you were away from the boat, it's summertime, thunderstorms virtually every afternoon, a lightning strike occurs, a distance away from the boat, but could create a power surge and affect your galvanic isolator on your boat then?
Yes.
So, okay.
It's important to do, yet I have to be honest, I doubt that a lot of people within the industry, boat owners or boat operators, really do that. It's a part
with
of
any
our...
luck at all, a couple of them will go.
Hopefully so. Or find a qualified technician to do it. Again, it's not a difficult test. It's a standard part of our corrosion survey that we do for boats. But it's a qualified marine technician or electrical technician can perform the test.
If I were to ask you to thumb back through your historical records and from when we used to do electrolysis surveys now and we do galvanic corrosion surveys, what would you say is probably the #1 issue that you've run across in compromised integrity of these systems?
Probably going back to what we just talked about, the galvanic isolator, grounding a boat back to the dock. And today, if you look at just take the large center console vessel industry, how much these really big boats with at least dual, triple, quad outboard motors in seawater with shore power always, if the galvanic isolator is #1, or if it's not installed, or if it's installed and it's defective, or sometimes we've seen them installed not correctly electrically, it can cause the aluminum, the outboard engines, aluminum corrodes very easily if it's not protected. And we've seen a lot of damage to outboard engines because of either galvanic isolators not being installed, defective, or improperly installed, bypassing the isolator. That's probably one of the most common problems.
So integrity of the system by bonding wires, the ends corroding off of them because they lay in a bilge with a little bit of seawater, and that's probably been one of the #1s. But that's a very interesting point that you bring. And today, the galvanic isolators are there to perform a very specific function, but they're kind of out of sight, out of mind, and people don't think about testing them and checking them.
And it's true, going back to what you were talking about with cathodic bonding systems, these systems being in bilge areas are a very tough environment.
Right.
So you're right, corrosion of terminations and connections can cause, remember we talked earlier about it doesn't take much resistance to block that protective current flow from anodes. So corrosion to terminations where you have a bonding conductor connected to a through-hole fitting or a piece of running gear with a ring terminal, and if that becomes corroded at the interface, there could be enough resistance to block the protective current flow. And typically, nothing is found out until you start experiencing corrosion problems.
Until your propellers turn nice and pink.
There you go.
Yeah, and the bonding system is much like a tree in the respect that you've got a trunk or a main line, but you'll have branches, and then you'll have some small branches off of that sometimes as well. So every component isn't interconnected into the main line directly. It can come through another connection or a series of connections into that bonding system, into that closed loop, if you will.
Yes, and it's in installing cathodic bonding systems, it's always best, as you mentioned, having a main conductor running through the boat and actually connecting to what are called bus bars in a major compartment or area, say within fixed bulkheads. And rather than what we might call daisy chaining, where you're connecting bonding from one fitting to the next, if you have a failure of a connection at the beginning of that point,
the whole system,
everything downstream from that is lost. So it's best electrical practice is to install a main bonding conductor through the boat, have bonding bus bars in each major compartment, then go out with individual conductors to each through-hull fitting or piece of running gear you want to protect. Best system.
And is that always the green wires?
Yes.
Okay. All right. You know, I think I've learned a lot about bonding that I didn't know before. I thought I had a pretty good understanding of it. I now know it's not electrolysis, it's galvanic corrosion. So that's a win for both of us. Ward, thanks very much for your time. Your expertise is unbounded, no doubt about it. I really look forward to future yacht engineering seminars where we can dig into other parts of the electrical system. We're going to learn a lot more from you. Thanks very much, everybody, for joining us. I hope you enjoyed that segment. We're going to cut to a commercial break.
We'll be right back.
Hi, I'm Bob Allen, and I work with a law firm known as Robert Allen Law. We're a law firm dedicated to serving the needs of people in the yacht industry. And that means manufacturers, that means brokers, that means buyers, that means sellers, that means banks, that means people who sell all sorts of things and services to the yacht industry. We're a team of lawyers that has experience in virtually all the fields surrounding this business. And if you're in the business, you know how important it is to work with lawyers who know yachts, right? And know the type of problems that arise and know how to solve them. Our job as lawyers is to help deals get done. Thanks for the opportunity to be of service to the industry, and we look forward to hearing from you if the need arises.
Michael here, founder, Concord Marine Electronics. I've got a lot of customers that ask us how it is we've been in business for over 32 years. And you could take a look at our glowing Google and Facebook reviews for yourself. But our customers tell me they come back because our proposals are so accurate and our service department is second to none. And on top of that, we've got the technical depth to handle any problems that might come along. We're proud to announce that we've just opened a new location at Lauderdale Marine Center where we're closer to our customers for better service. So when you or your customers are ready for electronic systems completed on time and on budget, call the experts at Concord Marine Electronics.
Dockmate is a small, handheld, wireless remote control for boat operators. It wirelessly controls the boat's engines, thrusters, anchor, and horn to eliminate those difficult docking situations and give boat owners a better boating experience. Our two-way communication between our remote and our receiver provides the redundant safety features owners are looking for. Dockmate is the only wireless remote control that can provide you with smooth, variable, proportional throttle control. Our proprietary customizable software called Dock Control allows us to personalize the Dockmate twist exactly to the owner's specifications. Give yourself a better boating experience and install a Dockmate today on your vessel. DeAngelo Marine Exhaust was founded in a small shop in Fort Lauderdale in 1986. Today, we occupy over 30,000 square feet of state-of-the-art manufacturing and engineering facilities. We produce, service, and repair marine exhaust systems and diesel particulate filter systems. For more information, go to DeAngeloMarine.com. Marine Data Solutions. Our affordable, high-speed internet keeps you connected. Marine Data Solutions is proud to provide superior wireless internet for yachting, 10 times faster than your VSAT at a fraction of the cost. Our unlimited internet service includes no throttle, no contract, no activation fee, no overages, no surprises, and same-day shipping with 24/7 tech support. Check out our Bahamas airtime package, 300 gigabytes for $350, no throttle. And we offer unlimited gigabytes of unthrottled, high-speed mobile internet service throughout the continental United States, a fixed low monthly cost, and no long-term commitment. Call us today to find out more about the best high-speed marine wireless internet. We ship SIMs and equipment anywhere in the world overnight. We are Marine Data Solutions.
Welcome back, everyone. Paul, I take it Wards gave you the full rundown?
They absolutely did. I think there's no question now that everybody knows the difference between bonding systems and grounding systems. And I think it's a really good thing, Heather, that you got to sit that segment out, because you're going to need your rest. We're about to meet Malcolm Elliott from Florida Nautical Surveyors. Let's go find out what it takes to be a surveyor.
All right, I'm ready.
All right. Welcome back, everybody. We're here for another interesting segment at LMC. This time, we're out in the yard and we're joined by Malcolm Elliott from Florida Nautical Surveyors. And Malcolm's going to give us a little primer, or give one to Heather, on surveying on boats. So, Malcolm, I got to tell you, it's a real nice opportunity to spend some time with you where I'm not worried we're going to have a deal come apart. So,
well, finally, Paul, I'm going to teach you about surveying.
Well, it's,
right?
it's
30
about
years.
time.
30
it's been
years.
a while.
Right.
It's been a while.
Okay.
So what we've got is some of the tools of the trade that you've come to realize reveal a lot of the secrets when you're surveying a boat, different types of materials, different considerations. Why don't you take an opportunity to show Heather through the different pieces of equipment that you'll use to get to the bottom of the condition of a boat, if you'll excuse the pun, and why we use the different ones on different materials.
Okay, no problem. So Heather, basically you've got the majority of the boats are fiberglass. Okay, that's what the bread and butter is. But you also got steel boats, you got aluminum boats, you got wooden boats, and you've got cement boats.
Wow.
Yeah.
Who would have thought?
Cement, straight down, right?
Exactly.
However, what I've done is I've laid out a number of gauges here, just the tools that surveyors we use, right? Now, all our gauge, because we do work for the classification societies and also the US Coast Guard, all our gauges that you're seeing here are certified. So that means we got to send them back to the manufacturer, have them calibrated, and it's like every year we have them calibrated, and we have a certificate for that.
Okay.
So on the fiberglass boat, you can imagine basically it's like layers of fiberglass, okay? And sometimes you get what we call blisters. Every broker hates blisters, right? Every broker hates moisture meters, because they think as soon as a moisture meter comes out of the bag, boom, the deal's under it, right? But with experience, you use a moisture meter, but you don't haul a boat out. You can imagine hauling a boat out the water, the bottom's wet. Mm-hmm. So some surveyors come along, bang, put a moisture meter on. It's wet. Right? So when we do a moisture meter test in the bottom, we are basically saying it's got to be out the water for 3 to 5 days, depending on the vessel itself. But besides the moisture meter, I'll go into a little bit more about the thermal imaging. We have thermal imaging cameras here. So that gives us a better idea even when the bottom is wet.
Okay.
So on here, because we do the classification, Coast Guard stuff, these are all certified once a year, which is very expensive because these got to go back to England.
Oh, wow.
These ones, right? So these are our main gauges. And basically you're putting these on and you'll see the gauge going up and down. See?
Okay.
Okay, so we're finding moisture. Those are the gauges we're using. This is like a much cheaper one. We don't certify these ones, right?
Okay.
This is like I think it's a $1,500 or $1,800 meter. This is like I think about $400. A lot of the surveyors use these and they just slide them around and they're not very good. And then the latest one is a thermal one, a thermal moisture meter. So we're starting to use these. Our guys are getting more used to them, but all of my team have got one of these. Okay, I've got two. And that's fiberglass boats. Now that's when we're checking for moisture when the boat's been out the water for 4 or 5 days. However, you can imagine the layers of fiberglass. Okay.
Okay.
When the boat first comes out the water and when it's wet, we have a good look around. Right. As soon as it's come out the water, we're looking for blisters, because like the sheen on the bottom of the boat, like any broker listening to this is why you see a good surveyor walk around the boat when it first comes out the water. We do that because with the sheen on, we can see blisters, we can see where previous repairs have been on the boat. So we walk around doing that, okay? Then we come to the magic hammer. Phenolic hammer. If you look carefully, this used to be square, right? Over the years, this has done a lot of work. We use this on the bottom of the boat. When we're tapping on the bottom of the boat, we want to hear like a nice ring. And we got a chuck. We keep tapping. No, but we're tapping on the bottom of the boat. And if there's the layers of fiberglass, if they come apart, you'll hear like a dull drum sound. Okay? So it's like it's a really dull sound, right?
Okay.
When I teach my guys, they're all I said, don't miss delamination. And they're all nervous until they hear it the first time, and then such striking noise between a nice clear, like a bell ringing, to a broken bell, right?
Okay.
So that's the phenolic hammer. That's the famous phenolic hammer. This is just this is a hard plastic that we use on the top sides, on a cleaner surfaces, right?
Okay.
And that's the moisture meters we use on the fiberglass, right? Now, when we're checking the bottom of a boat, and this applies to all boats, no matter what the material is, right? We go along, we use this hammer. You see the gap there?
Yes.
Okay. This is actually, if you can look on there, it's called a tack hammer. And they used to put a nail in there and the hammer tacks there.
Oh, okay.
However, what I use it for, when we tap on a metal, like a nut, a propeller nut, nuts and bolts around the swim platform, when we tap on it, there should be a nice ring, really. If we tap on a prop nut and there's the dull sound, it's usually loose.
Okay.
So that's how we test for the tightness of nuts on propellers and swim platforms, anything that's metal underneath the boat. Right?
Okay. So these are used on metal. This is used on metal.
Well, this is used on the metal parts.
Okay.
On a fiberglass boat.
Okay.
The metal parts on a aluminum boat. This is used on any boat.
Okay.
Right.
Metal parts.
Yeah. This one is used on a fiberglass boat.
Fiberglass
We
boat.
go underneath. We tap on the.
Got it. Okay.
This one here, I use on wooden boats. Okay. Now there's pure wooden boats, or there's cold molded boats with a fiberglass on the outside. It's basically they have a frame, they lay the planking up with a diagonal planking on, double, triple diagonal planking. When we come along here, what I'm wanting to hear is, again, just like the fiberglass, but I'm wanting to hear that the plank is well secured to the frame on the inside.
Okay.
So that's what we use that one. It's a different sound. I find that these, to my experience, is better sound that I'm hearing on the bottom.
Really?
Yeah.
Interesting. So you use wood on wood.
Wood on wood, yeah.
Okay. Interesting.
You get that, Paul? Wood on wood.
I got it.
Okay.
I got it.
Now,
if you hand me that phenolic hammer, I'll become a surveyor.
There you go. You need a shirt. Now this here, this is a vernier caliper. What we're doing here, this is only up to a certain size. We've got different calipers. But if you've got a shaft coming out and you want to know the size, we go like that, and we get the size of the shaft.
Okay.
Okay. So it's one of the details we're going to get.
Okay. And what detail would that be used for?
Just in our report that we know that it's like a 2-inch, 3-inch shaft on a 1500, 1800 horsepower. Smaller boats will have smaller diameter shafts.
Okay.
Okay. This one here, these are long feeler gauges. And feeler gauges, when you get as old as me, doing surveys, you find yourself. Okay. No, but these are feeler gauges. So you can imagine the shaft coming through from the boat, and you've got a strut.
Okay.
And there's a bearing there, okay? And we use these to measure the clearance between the shaft and the bearing surface.
I see.
Okay. Now when the bearing, when it comes, when you hold out the water, the shaft and the propeller, the whole weight drops down. So there's only clearance, there should be only clearance at the top.
Okay.
And what we are measuring for, if you imagine looking at a strut, the strut is the support for the propeller shaft.
Actually, Malcolm,
Right.
Heather's familiar with the strut because we did a segment with AME where she took a dead hammer and she hit the strut on a big
I
Fed
did.
ship that was out of the water.
I
Now
sure
I'm here
did.
to tell you, we had a special camera registering the vibration. That thing did not move. But when we looked at the chalking blocks, she moved that boat on its keel. That girl's got a swing.
Well, Heather, obviously you know. So let me talk to Paul because he won't know, right? Anyway, so what we're doing is we're looking at where the strut is, the shaft. So we're looking because of the weight. If it's perfect, it's dropping down. We're getting clearance between like 10 o'clock and 2 o'clock, just because
Okay.
it's coming down, right? So we measure with the feeler gauges what the clearance is.
Okay.
This is another gauge that we use as well. Okay.
Okay. And what is that used for?
Again, it's measuring the clearance between a cutlass bearing and the shaft.
Okay.
For a long time, all cutlass bearings were just rubber, right? Nice soft rubber with waterways through. Waterways through, because any bearing, when the shaft is spinning, there's a film of water. And it's the shaft shouldn't be touching the rubber. There's a film of water underneath. So you have these waterways that go down through the length of the cutlass bearing. Nowadays, because of the high horsepower, what they have is it's like an epoxy composite bearing. It's like a nylon plastic bearing, and they don't go by the clearance. Okay, what they do is we go from the top of the waterway to the shaft. So we got to slide. It's like this, like a groove like this. We got to slide this in, and we got to check the clearance like this.
Okay.
But it's just another tool. The spike. On a wooden boat, we can come along and spike the bottom. Right?
Now, what does that mean?
Okay, so on a wooden boat, if you've got any softness in the plank,
Okay.
we can, when we tap on the bottom, and we can hear maybe the softness, right? We're listening to if the wood itself is sound, and if it's tight to the frame on the inside. And if we're hearing like a dull sound, what we can do is come along with a spike. And a lot of people don't want to hear this, you know, but we actually push it into the wood, okay?
Really?
Yeah.
Okay.
And if I've seen me just push it right through
Oh, wow.
on a really bad boat, right? Just,
So that's obviously not good. We don't
No.
want it to push through.
Right.
Okay.
And really, when people say, "Oh, you can't put that into my boat," well, sir, if I'm pushing my finger and it's pushing into the wood,
You've got bigger problems.
I've got bigger problems than me putting a spike in. You know, so that's the difference on there. Okay, so on any boat as well, we're looking for the bonding system. Okay. Now, on the bottom of a boat, you have different dissimilar metals. Okay. So you maybe have your bow thruster, your through-hull valves, you know where the fitting is there. You got your shaft, right? So you might have some bronze, some alloy, some bronze through hulls. You have a bronze, maybe stainless steel strut, stainless steel shaft. But all stainlesses are not equal, okay?
Really?
Exactly. So you can
Okay.
have different grades of stainless where
I
they
didn't
will
know that.
corrode as well.
Okay.
And again, on the rudders, they can be bronze, they can be stainless steel. And some boats have got a stainless steel frame and the rubber. There's rubber molded around them, right?
Okay.
So you got all these different materials on the underwater side, but being in the water, it makes it a common. Okay. So when you get electrolysis, like corrosion occurring,
Okay.
it goes to the softest material. That's why you'll see on some of the boats they have a zinc on the transom.
Okay.
So that usually means that the bonding system, everything inside the boat, is bonded together to make it all common, and it goes back to the zinc, making the zinc is the softest material. It's either a zinc or an aluminum alloy. Okay. So what we do is we got long leads, we got a meter, and basically what we do, and we want to see if there's continuity between this fitting and the zinc, the shaft and the zinc, the strut and the zinc,
I see.
and the rudder and the zinc. So we want to make sure it's one big circuit. So it's the sacrificial zinc anode. The sacrificial being an important word, right?
Yes.
So the sacrificial zinc, which is maybe anything from $50 to $200, that'll be corroding away, as opposed to maybe the $30,000 propeller.
I see.
Okay.
So now how do you measure that exactly? You use...
Well, basically what we're doing is, if we're looking for the resistance, right? So we put a lead from here to here. I won't put all this out, but...
Sure.
Right, so say you're the bow thruster, right?
Okay.
On the through hull, we snip this under you.
Okay.
Right? This lead comes back to here.
Gotcha.
And then this from here to the zinc.
Okay, I see.
So we want to see there's a circuit right through.
Okay.
Right? And there's not, well, we got an issue. We want to see a complete circuit there.
Okay.
And there's quite often is like in the, excuse me, you know, the through hull valves on the inside of the vessel are lowered down. So the wire comes into the through hull valve, and even if they're connected correctly from the originally, if they have some water in the bilge or just getting old, they'll corrode off, they'll come away. Same on rudders, they have them on the tiller, and when that's moving all the time, that wire can like fatigue.
Sure.
And the wire will snap off. So you just come along, you put this onto the rudder, you put it to the zinc, there's no circuit, we got an issue with the bonding system.
Okay.
Right, so now, that's basically fiberglass. So we talked about the blisters in the bottom. The
Yes.
blisters are basically, I talk about blisters being...
Is it what you imagine, like a blister that you would get on your hand?
Yeah.
Similar to that? Okay.
It is. But I say blisters because, you know, some people make a huge thing of blisters, okay? Back in the 80s, right, there was a big, 90s, there was a big thing because in the Cruising World magazine, they wrote this thing over like 3 or 4 months. Oh my God. One blister on a sailboat that did, right? It was a big thing. I say blisters are like a spot in your face.
Okay.
It's not going to kill you. It doesn't look very good, but it's cosmetic. Up to the point of, if you have a blister, what I say to some people, if you go along and randomly mark out 1 square foot around the boat, and then go back and count the blisters in there. So if you've got 6 random spots, and you've got 10 blisters in each square foot, you may have to consider doing a full strip job on the bottom.
Okay.
That means peeling off the paint, the gel coat, checking the fiberglass for any voids, applying epoxy barrier coat, and then the paint back on.
So when you get that many, that's when it goes
That's-
beyond just cosmetic?
Yeah.
Okay.
Now sometimes as well, when you get the blisters, when you pop the blisters, right? You know, you got a blister, oh, it's a blister.
Yeah.
So now what you do is you go along, and you actually, what I do is I get my spike, we see a blister, and you got to be careful, right? Because if you pop it and it squirts out, it's like it's like, the best way to describe it is like a sour vinegar.
Oh.
Okay, when you smell it, it's like, ugh, you know. So you get this fluid coming out, right? But it squirts, it goes in. Trust me, I've had it in my eyes. So anyway, you put your hand over, burst it, and then smell it. Okay.
Okay.
Because sometimes you get blistering in where the fairing is. So the vessel, you know, it's fiberglass boat. We're talking about fiberglass just now. But you got a fiberglass boat, but where maybe a bow thruster has been installed, or the shaft comes out, or the rudder, they put fairing around there, fairing compound, make it nice and smooth and whatever.
Mm-hmm.
And a lot of the time you get blistering in those areas, as opposed to the hull's good, but blistering around the smaller areas.
Mm-hmm.
So we gotta check to make sure that it's a proper gel coat blister and not just a blister in the fairing.
Okay.
And we use that just to smell it. So going on to aluminum boats, aluminum and steel boats. Okay. We have different gauges over here. This one here, again, this is one of the latest and the greatest ones. I think it's this one. We have a lot of these gauges, right? So what it is we're using these to get the thickness of the plating. That's this one here, right? This is one of the latest audio gauges. Okay, this is one of the top brands here. This one here is very good as well. We were using these for a number of years, but I find for accuracy, we find that we use these are much better. The Coast Guard like these better as well. So, but let me explain about
Now, what do those do again?
That measures the thickness.
The thickness.
Yeah.
And how does it do that exactly?
It sends a signal out through one of the ports.
Okay.
It sends it out, and then for the receiver, takes the time for the signal to go out and then to come back again, and you get the thickness.
Interesting.
But on here, we're measuring right down to thousandths of an inch.
Right.
Okay, we can do that. Again, though, with the audio gauge, we have. I joke around that I bring these for most yacht brokers. This is called a couplant. Okay, so anybody that's been married and got kids and they've gone with their wives, or you've had it yourself, you're a lady. When you get a sonogram done for the baby, for the picture, they put a couplant. And what that does, and what we use it for as well, is put the couplant between the surface and the probe, and that takes out any air. Because if we get any air between the probe and the material, it's a false signal.
Okay, interesting.
The same as when we say our meters, that's an important thing. Our meters are non-destructive testing.
Non-destructive?
Non-destructive, meaning we don't have to take the paint coatings off.
Oh, okay.
Right, so some guys, they have destructive gauges. You'll go into some boatyards and you'll actually see like grind marks all over the hull. Right?
Now, why would they do that if they have this?
No, they don't have this.
They don't have this. So that's
these
why
are
you're
expensive.
the best.
These are expensive.
Okay.
So these are expensive. So
I
you
see.
see, that's the difference between using a gauge like this and using a gauge like this.
I see.
Right?
Okay.
Actually, I don't have a cheap one. So, but no, it's a big thing because we can go along, and I tell people though, so long as the coatings are well adhered to the metal, whether it's being steel or aluminum. And even we're using the couplant, because the couplant goes between the probe and the paint to measure the steel. Okay. But if the paint is not adhered to the steel, that's got air in there. So when we put this on, we're getting a false signal.
Will you know if it's a false signal?
Yeah.
Okay.
Yeah, it tells you. This is the beauty of spending money, right?
Wonderful.
But again, on steel, if you go into a boatyard, you see, or any yard, you see a sheet of steel, you'll see the steel like a big rust, like a sheet of rust, right? And steel boats, you'll get, it's pretty important, it's actually more important using audio gauges because you'll have all the sheet corroding. And you'll have, you can tell the thickness of it as you go around. On aluminum boats, the biggest problem with aluminum boats is the spot. You get, what's the word I'm looking for? Yeah, you're getting corrosion, but you're getting marks right through the whole thing. That's not the right word I'm looking for. Come on, Paul. Pitting, sorry, pitting.
Pitting,
Pitting,
okay.
there you go, pitting. So you're getting pitting around the bottom. So you can put the probe on, and I've seen this. We can go along here, but look at the size of the probe. If you got but if you've got an 80-foot boat,
You got to take that thing around the hole.
you got to go along.
Oh my goodness.
Right? So I've actually seen putting this on and then looking and getting a scraper, and where to like an inch away from this, there's actually a hole goes right through.
Wow.
So, again on aluminum, you've got to with experience. I'm old, I'm experienced. I've a lot of background in this. As a brokers, you shouldn't just pick up any surveyor. It's an 80-foot boat, you survey it, right? Has he got the experience of aluminum and steel and
Sure.
being able to look, because I can look at an aluminum boat and it's like a slime appears in the bottom of the boat when it's corroding. It'll be below the paint, but it's a slime, right? So to look at that area and check it all out, right? So yeah.
Now let's say there is an 80-foot boat, and how do you know which spot to pick? Or how do you know
again,
exactly where to go?
That's
Just
the
expertise?
A very, very good question, right? What we do is on steel or aluminum, and again with experience, but we normally ask that we can survey the boat in water the day prior to hauling it out, or 1 or 2 days before. That way we go through the bilges, we look at the vessel's drawings, and we get to know where the tanks are, okay? Now I'm not saying anything bad about Broward yachts, right? But I know I've done a lot of Browards, right? The holding tank, the black water tank, is between the engines. Okay, it's an integral tank. That means the bottom of the hull of the vessel is the bottom of the tank. Okay, the sides of the tank is underneath the engine bed stringers. That forms the engine bed, right? And then the tank top is between the engines. So normally what we ask is that, because I know where the tanks are, I know where the water tanks are, I ask that the day before we actually come to a haul out, the tank is flushed, emptied, flushed, and we stick our head in. 2 reasons. We want to see, like there's usually like an area on a tank which is fairly consistent of being right on the surface, right? Maybe it's an automatic pump out, the fluids come up, the automatic kicks in, and so it's this area here. Holding tanks and freshwater tanks have got coatings on the inside, you know, because there's a lot of, let's say, undesirable fluids that's in that tank.
Of course, right? Of course.
Right? And if you stuck your head into a freshwater tank, you would never drink fresh water on the boat. Right? It's the scale in them, it's pretty scary. But on a holding tank, we want to put our eyes onto the coatings. And again, because if it's aluminum, you know, we might say, oh, the holding tank's good. But when we look on the inside, that we're finding very, very poor, very poor.
Okay.
So we use that. On the bottom as well, we use this gauge. This is a fancy gauge here. You can imagine, if on an aluminum boat, we have a pitting here. We were just using this on the Coast Guard this morning, right? So we can go along with the audio gauge. We can say that this plate is, say, maybe is a 1/4 of an inch, okay? Then we use this, if there's a pitting in the aluminum, we use this gauge and we lower this down into the hole. So then we can measure, you know, from the flat surface where the pitting is, right? So it goes down like this. So we measure down, because at the bottom of that pit, it might just be paper thin.
Okay.
Okay,
I
you understand
see.
that one?
Yes.
Yeah, so this is, it's basically like that, look. This
Okay.
is, you know, say that was, and then we push this down, we get the depth of that's how deep the hole is.
Okay. Now, at what point is too deep of a hole, would you say, or does it differ?
No, it's, that's a good question as well. You have good questions,
Thank
don't you? You got to teach Paul a little bit here.
He's got a lot to learn.
Yeah. Yes, a good question. Now, we've worked with the Coast Guard, and you know, a Coast Guard inspected vessel, and we've actually, I'm not going to say we've gotten away. We've come to an agreement with the Coast Guard that we've gone to 25% of plate thickness wastage. Okay, that means like I'm European, I can work easier in metric, right? So if you've got a 10 millimeter thickness plate, 25% is 2.5, right? 2.5 millimeter. So we measure the plate with this, it's 10 millimeter. Then we come along and measure this, and the hole is 2.5 millimeter. That's the maximum it can be.
That's maximum, okay.
However, if we go along to, say, RENA, the Italian Society, they'll, again, we've worked with them up to about 17, maybe 20%. But you go to Jeremiah Lloyd, it's down like 8 or 10%.
Wow.
Right? Now, what a lot of people don't understand as well is steel and aluminum plate. You might think that you have 1/2 inch, but it's like going to Home Depot and buying a 2x4. It's like, when I came to America, it's like, why do they call it 2x4?
Right.
It's not nowhere near being 2x4. So anyway, on steel or aluminum plate, it's nominal size, right? If it was for the US Navy, wow, it's got to be perfect. So it'll be 1/2 inch plus or minus maybe 5 thou. If it's a builder that's buying cheap plate, it might be plus 1/2 inch plus or minus 30 or 40 thou. So when we're measuring it, we got to bear in mind, right? So it might be when 1/2 inch is 0.5, when we measure it, it might be down to 0.445. Okay.
Okay.
So we got to bear in mind, you know, if we have, if the drawings are available and we can find out what the nominal thickness is, it helps us a lot in there. So that's that's what we do on steel and aluminum. Okay. Now on the boats as well, we have gauges where we can measure the paint thickness.
The paint thickness.
Yeah.
Really?
Yeah. So
Okay.
so these gauges, what we do is on the top sides. I've seen there's like a dispute when like a painter, when they're painting the boat, you can see through it. Okay. And people have said, hey, you didn't spray it enough, there's not enough paint on there. I hate paint surveys because it's always a dispute. And it's like the eye of the beholder. You look at it one way, it's great. You look at the other one, it's like, oh, right? Orange peel, that's the effect in the paint. And then, but we got these gauges where we can come along and we actually measure the thickness of the paint. This gauge here and this gauge here, this goes through the paint and just measures the metal.
Right.
But these gauges here, I've got one for steel and one for, one for metal and one for fiberglass. So we can use these, and all we're doing there is measuring the coating. We're calling it paint. We're measuring the coating thickness on the vessel. So, and then we have the thermal imaging. Everybody thought when thermal imaging came along, it was going like, wow, this is fantastic. It's good, but it's got its limitations as well. Okay, so we got $30,000 camera.
Wow.
And we got, I think these are 15 or 18,000. Okay.
Wow.
Sorry,
okay.
100. That's 100. Sorry.
100.
100. Yeah. But I find that when we're using these, it gives us a kind of a guide on the bottom. You know, it tells us. You know what I say a lot of the time? We got this. Actually, this is the tools of the trade, right? You've got a $30,000 thermal camera. You got a 1,500 moisture meter and a $2 hammer. We can.
Which one tells you the most, Malcolm?
Well, after 30 years of going ding, 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 this is the one.
You got a lot of repetitions with that one.
So this has made me a lot of money, and it's saved a lot of people a lot of money as well, I'll tell you that. But that's basically the tools that we use. We gotta, you know, some people want to know the sound inside the boat. So we can measure the sound out here.
Huh.
So if, you know, some people want to know that if they're sleeping in the master cabin,
how noisy it is.
And how noisy it is. So we got to go along and take a decimal readings.
So
Wow.
in short, you know, what we've learned here, Heather, is that the primary focus of what Malcolm has talked about has been the underwater component of the survey, because it's really one of the most important parts. If the bottom of the boat is tight, then we can go on to the rest of it. If we have a problem with the bottom of the boat, it becomes a big problem right out of the box.
Sure.
Fiberglass, we have one way of determining the condition, if it's delaminated, if it has blisters, if it's in good condition. Metals, we use different instruments for different types of metals, but the long and the short of it is, what we're trying to determine in survey is the condition of the boat. Malcolm's been wanting to put a decibel meter on me for at least 25 years. I'm afraid to see what the results are. I think our audience probably knows what a decibel meter is going to be.
It's kind of high pitched. You know, I'm good at deep voice, so oh no, look, what's yours like?
I don't know. Let's see.
You got the deepest voice.
Really? Oh my goodness.
The one gauge you didn't show us was the BS meter. So if we're going to hook this,
this is okay. To all you brokers, IYBA brokers, anybody, this is what Paul and I met with. He was bent over, and I was doing the boroscoping. I believe it was on a Detroit 692.
But the second time you used the gel.
Oh yeah, sorry, the second time.
Thank you so much.
No, but this is the boroscoping. That's we use that normally more inside the boat, and that's replacing that now with your smartphone.
So we have a different one, then that reads to your computer.
Yeah.
Malcolm, this has been fascinating. There's so much to it. You know, I think everybody understands there's a lot to surveying a boat. And one of the things that you alluded to that's critically important is choose a surveyor that's familiar with the materials of the boat that you're going to be surveying, because it's his experience that tells him as much, if not more, than all the fancy equipment and all the high-priced technology we can get our hands on.
I totally agree. It's you know, we're super busy, and I get super busy with a lot of I hate to say consultancy. It sounds a fancy term. People call me and ask me, so I guess It is consultancy. But it's you know, like nowadays everybody's so busy with work, thank goodness. But there's a lot of people become surveyors. And they go out and buy basically a hammer, a moisture meter,
A clipboard.
don't forget that, right? And that's about it.
And you're a surveyor.
And a flashlight, right?
Right.
And they go out and, I don't know how some of them are surviving, and I just don't. I get involved in a lot of legal cases as an expert, and it's scary what goes on. So
There's a lot more to learn. There are a lot more components to the boat. We've got a lot of other segments where we've learned other things, and a lot of the things that we've talked about in other segments, Malcolm's brought to light here as well. That's all we have time for in this segment. Thanks very much, folks, for joining us in this one. I think we've got a great handle from Malcolm Elliott at Florida Nautical Surveyors. We're going to break right here, cut away to a commercial, and we'll be back.
Florida Nautical Surveyors is your complete solution to all your vessel surveying needs. Our team of seasoned experts led by Malcolm Elliott are the go-to solution for pre-purchase, insurance, or valuation surveys. Whether your vessel is steel, aluminum, fiberglass, wood, or even ferro cement, our surveyors have the knowledge and training to meet all of your surveying needs. Call Florida Nautical Surveyors today at 954-801-2140. Or for more information, go to floриданauticalsurveyors.com.
Our industry has learned that to control your data is to control your destiny. Yachtbroker.org is the key to that control. As a member of any professional yachting association, when you input your data, you are the owner of that information. At Yachtbroker.org, you can keep track of all data reports related to your company by viewing your customized live management dashboard. Create an eye-catching photo gallery with our new thumbnail editor. Follow vessels of your liking to get status notifications in current time. Identify special commission conditions immediately, and even report a vessel to our team and the listing broker. Need to have access to your fleet on the go? Yachtbroker.org is completely mobile optimized, so you can view and edit your listings from anywhere in the world. For more information on how you can get started using Yachtbroker.org, give us a call at 954-522-9270 or email me at casey@iyba.org.
Marine Professionals MPI has been in business since 1997. With over 20 years of experience, we at MPI provide you the very best in marine electronics, audio, video, and networking. We specialize in boats from 40 to 120 feet. If you need navigation, including Garmin, Raymarine, or any other top brands, MPI is your go-to source. If you need audio video equipment, MPI can provide you with HD TV and the very best sound with a Sonos hi-fi sound system. MPI is the only marine gold Sonos dealer in the country. Nowadays, everybody wants high-speed internet. MPI can offer you different solutions that fit your needs. Whether it's to pick up the marina Wi-Fi, cellular, or satellite, MPI has you covered. We'll make sure you can binge watch your favorite Netflix episodes anywhere, anytime you want. You can check us out online at marineprofessionals.com or call us today. I'm Mark Carreri, and I approve this message.
At Murray Ventilation Products, we bring over 20 years of experience providing ventilation and air filtration solutions. MVP is your most valuable player in demisters, intake and exhaust fans, and computer-controlled safety systems. We are well equipped to provide end-to-end solutions for OEMs and refit projects the world over. Call Murray Ventilation Products today at 772-631-2229.
Maritime arbitration has been around for hundreds of years. Now we have a new forum to solve our disputes. The IYBA has created the International Yacht Arbitration Council to solve our disagreements. We have experienced maritime attorneys and yacht brokers to serve on our panels, people who know the law, who know boats, and who know the yacht business. IYAC arbitration can handle yacht claims, contract, purchase, and commission disputes privately, quickly, and less costly than going to court. Sometimes disputes happen, and when they do, the IYAC is here to help you solve them.
above.
All right. Well, that was interesting, Heather. Malcolm certainly knows all the different nooks and crannies when it comes to surveying, doesn't he?
He sure does. I think I'm ready for my surveyor's cap. All I need is a clipboard and a hammer.
It's all it takes. That and a couple of $10,000 instruments.
I'm good
and
to
you'll
go.
be in business.
I'm ready.
All right. Well, that's it for today, folks. We've had 3 great segments. We saw a little bit about the business model here at LMC. We talked to the folks at Ward's, and now we've learned about surveying from Malcolm Elliott. That's going to wrap it up for day 2. Thank you very much for joining us. Heather, when do you think they ought to come back?
9 a.m. tomorrow morning. You know where to find us.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs.
He sure does.
And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers,
Good to go.
AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thanks for joining us. See you tomorrow.